In the previous section, we learned about how to evaluate sine and cosine functions by using coordinate. In this section, we want to understand sine and cosine as functions. That means we want to figure out what the domain and ranges are and how functions graph look like. Let's consider the unit circle. Let's say this angle is theta and this point is x and y. In the previous section, cosine of theta was defined as x over r. We are considering the unit circle, so the radius is 1. In this fraction, the denominator becomes 1. That fraction is equivalent to x. By doing that, we realize that the cosine of x is identifiable with x coordinate on the unit circle. Let's consider sine of theta. Sine of theta is y over r. Again, the radius is 1, so the denominator becomes 1. So fraction can be reduced to y. Again, the sine of theta is identifiable with the coordinate of y on the unit circle. Let's summarize that. On the unit circle, coordinate can be rewritten as sine theta and cosine of theta and sine of theta. In the first section in this semester, we learned about the arc length formula. Let's consider the circle with radius r. We consider arc length then arc length was formulated as radius times radian angle so radian angle theta can be rewritten as arc length over radius. What you have to keep in mind here is radian angle theta is any real number. Another important thing you have to remember, keep in mind is if r equals 1, then radian angle theta is the same as arc length, which we often denoted as S. To understand sine and cosine as a function, what we will do will be we will attach the real number line to the unit circle like this. What we want to do is we want to wrap around the circle with this real number line counterclockwise and clockwise. What will happen will be when you wrap around real number line, the positive real number line will wrap around the circle counterclockwise, and the negative real number line will wrap around the circle clockwise. Other important thing is whatever the point on the real number line is, there will be exactly one point which is identified with that point. Let's say we have chosen S on the real number line, and that point is identified with the point on the unit circle whose coordinate is A and B. Then that S can be perceived as an arc length, and on the unit circle we already know that the radian angle is the same as arc length. So we can say that S equals theta. On the other hand, on the unit circle, X and Y coordinates are identifiable, cosine theta and sine theta in value. And we can rewrite that as cosine of S and sine of S. Here, theta has a geometric interpretation, that is an angle. S also has a geometric interpretation, that is an arc length. However, that S was chosen on the real number line, so we can just forget the geometric meaning of S, and we can just view that as a real number. As I said, if there is a point on the real number line, then that point will have exactly one point which is identified on the circle. And the coordinate of that point will determine sine and cosine value. That means whatever the chosen number on the real number line will be, there is an output value, right? So we can say that the domain of sine and cosine functions are all real numbers. When we consider the sine and cosine value, cosine value, which is defined as x value on the circle, is bounded by -1 and 1, and sine value, which is defined by y values, are bounded by -1 and 1. So we can say that range of cosine and sine functions are 1 and -1. Let's go back to college algebra class. Let me remind you the definition of periodic function and the notion of period. The function f is periodic if there exists a number, positive number, p, such that f of t plus p equals f of t for every t. That means if the given function is a periodic function, then certain pattern of the function will be repeated forever. The least such positive number is the period of f. The reason I'm talking about the periodic function and period is because sine and cosine functions are periodic function. Indeed, all trigonometric functions are periodic functions because we already know that coterminal angles, which can be differed by the multiple of 2 pi, have the same trigonometric function values. Let's go back to the unit circle. This is 1, 1, -1, and -1. And this is A and B. Let's say this angle is theta. Then on the unit circle, we already know that A represent cosine of theta. But if you think about this angle, which share the terminal side, so coterminal angle, then it has also the same cosine value. So cosine of theta plus 2 pi will be the same. We can just rotate over and over again forever. Let's say B is sine of theta. Then similarly, we can say that sine of theta plus 2 pi has the same value because those are coterminal angles. Generally, we can write cosine of theta equals cosine of theta plus 2n pi when n is an integer. We can say that sine of theta equals sine of theta plus 2n pi because theta and theta plus 2n pi are coterminal angles. 2 pi is the minimum value that makes happen. So period of sine and cosine functions become 2 pi. This is the important fact which we will use repeatedly, so you have to remember it clearly. Let's figure out how to graph the sine function. Before we do that, let's discuss the nature of the sine function. We said the domain of the sine function is R, and range of the sine function is -1 and 1, and we already know that period is 2 pi. We also know that the maximum value is 1. That is the largest function value. That is 1 because range is -1 to 1. Minimum value of the sine function is -1. Since sine function is a periodic function with period 2 pi, it is enough to draw the one period of sine function to figure out the entire function's shape. Let's consider the unit circle. Input value of the sine function is a radian measure of the angle. So let's label with the radian measure of the angle. At the point where the sine has 0 or maximum, this is 0, or minimum, this is pi, this is 3 pi over 2. Let's label it with a coordinate. Then this point, when the angle is 0, the coordinate is 1, 0. And that can be interpreted as cosine of 0 and sine of 0. Now we are working on sine function. So we can say sine of 0 is 0. This point coordinate is 0 and 1. That is cosine of pi over 2 and sine of pi over 2. This means sine of pi over 2 is 1. This coordinate can be written as -1 and 0. Again, that is cosine of pi and sine of pi. So sine of pi becomes 0. Pi is 0 of the sine function. The coordinate of this is 0 and -1, and that can be written as cosine of 3 pi over 2 and sine of 3 pi over 2. So sine value at 3 pi over 2 is -1. Then we go back here. So it can be rewritten as cosine of 2 pi and sine of 2 pi, and we can say that sine of 2 pi is 0. Let's consider the graph of sine in the first cycle. Graph of y equals sine of x on the first period, 0 to 2 pi. I said the maximum value of sine is -1 and minimum value of sine is -1. The important points are 0, pi over 2, and pi, 3 pi over 2, and 2 pi. Those are the points where sine values are 0, maximum or minimum. If the angle is 0, so x represents an angle, radian angle, and y represents the value on the y value of the unit circle. When sine value equals the angle is 0, sine value was 0. And when the angle is pi over 2, sine value was 1. And when angle is pi, the y value was 0. And the angle is 3 pi over 2, that was -1. And when that is 2 pi, that is 0. If you look at the unit circle between the angle 0 and pi over 2, y value gradually increases until it reaches 1. So all we have to do is we connect these 2 points smoothly. Between pi over 2 and pi, the y function value decreases and eventually became 0. So it became like this. And between pi and 3 pi over 2, y value still decreases and eventually became -1. So we will draw like this, and between 3 pi over 2 and 1, y value gradually increases until it becomes 0. So we complete the graph like this. As I said, sine function is a periodic function, so the same pattern is repeated forever. So this is a one period. Let's extend the graph which we drew in the previous page. We figured out how the first cycle of the sine graph looks like. So it goes like 0, 1, 0, minus 1, 0, and then it's repeating its pattern, so it'll become 1. When we go to the left, it goes down, so it became minus 1, and then 0 and 1. So we drew the graph of the function like this. So this is y equals sine of x. That is a wave function. What's really important to remember is sine is a wave function which oscillates between minus 1 and 1, and it passes this origin. There is an important notion called key points. Key points are x values in one period where the function becomes 0, maximum or minimum. In this case, we have period 2 pi. The key points divide one period into 4 equal intervals. So this is pi, and this is pi over 2, and this is 3 pi over 2. Later point, we will think about the horizontal stretch or shrink. When we think about that, the period will not be 2 pi anymore. In that case, you will just think about the first benchmark as period, which is 2 pi times 1/4. So period times 1/4. And then the second benchmark will be 2 pi times 2 over 4. And then third benchmark will be 2 pi times 3 pi over 4, and the last one is 2 pi times 4 over 4, which is just 2 pi. Or you can just calculate the first period, and then we can add the same number plus pi over 2 to get the next benchmark. You can go either way. We can draw the graph of cosine functions similarly. We already know domain of the cosine function is the entire real number. This one means entire real number. We also know that the range of the cosine function is minus 1 to 1 because we define it on the unit circle. And the period is 2 pi. Range is from minus 1 to 1. So maximum value is 1 and minimum value is minus 1. Let's consider the unit circle again. We will do exactly the same thing, focusing on the x value to define the sine cosine function. This is 0, this is pi over 2, this is pi, and this is 3 pi over 2. This is also 2 pi. The coordinate of this point is 1, 0. We can write it down as cosine of 0 and sine of 0. That implies that the cosine of 0 is 1. This point coordinate is 0 and 1. That can be interpreted as cosine of pi over 2 and sine of pi over 2. So we can say that the cosine value at pi over 2 is 0. Coordinate of this point is minus 1 and 0. That can be written as cosine of pi and sine of pi. So cosine of pi is minus 1. The coordinate of this point is 0 and minus 1. That can be interpreted as cosine of 3 pi over 2 and sine of 3 pi over 2. So cosine of 3 pi over 2 is 0. We go back to the original point, then we are getting to the coterminal angle. So cosine of 2 pi and sine of 2 pi, and of course cosine of 2 pi is again 1, as it was with cosine of 0. By using this information, let's draw the one period of the cosine function. Graph of y equals cosine of x on the first period from 0 and 2 pi. The benchmark will be again the values where cosine becomes 0, maximum or minimum. Those will be 0, pi over 2, pi, 3 pi over 2, and 2 pi. That is one cycle. When cosine of 0, the input, again, as in the sine function, x is the radian angle, and y is the cosine value. When the angle is 0, the cosine value is 1. And when the angle is pi over 2, the cosine value is 0. When the angle is pi, the cosine value is minus 1. And when the angle is 3 pi over 2, the cosine value is 0. And when the angle is 2 pi, the cosine value is 1. When angle varies between 0 and pi over 2, the function value start from 1 and decreases to 0. And then when the angle varies from pi over 2 to pi, the cosine value decreases. We are just thinking about the x value. Then from here to here, cosine value will decrease. So we will connect these 2 points like this. If we think about how x value varies between pi and 3 pi over 2, we just think about the x value. Then x value increases and then became 0. So it becomes like this. Then when we think about the cosine value, when angle varies from 3 pi over 2, the value become 1 from 0, which increases, x value increases. So we connect like this. This is the one cycle, one period of cosine. Cosine function is a periodic function with period 2 pi. So by repeating the same pattern over and over again, we can complete the graph of cosine. Let's do that. What is important to remember is cosine values start at the maximum, while the sine function start at the 0. And then it will go like this. This goes down, and it has the same pattern on the left side. So that was the maximum, and then it becomes 0, then it becomes negative, and it becomes 0. So this is the graph of cosine function. As I said, cosine function starts at the maximum point, zero, 1, and y-axis. This is a cosine function, and this is a sine function. Those look very similar. Indeed, cosine function is shifted to the right pi over 2 amount to be identified with sine function. What you have to remember very clearly is cosine function starts at the maximum point and sine function starts at 0. As in the sine function, cosine function also has a notion of key points. Those key points are the points where y value becomes 0, maximum or minimum. The way we are thinking will be the same. This is the period. The key points divide the period into 4 equal intervals. So, as in the sine function's graph, those will be 0, pi over 2, and pi, 3 pi over 2.